This problem is a system of masses connected by a cable sitting on a table. Pulley. One mass is dangling and the other mass supported by the table. We're told the masses and the first question is, what is the magnitude of the net force acting on the two mass system? I'm going to write down the values of the masses I have. Well, we could start drawing in some force arrows, some vectors that represent the different forces acting on the system. In this case, it would be M1G, and this would be M2G. And those are external forces, they're gravity from the planet. And then this upwards force from the string isn't considered a external force. It's this mass, the two masses connected by a string are considered a single system. So that one doesn't count. There is and just like the pull sideways on this mass wouldn't be considered an external force. There is an upwards force due to the table. The table isn't considered part of the mass, connected mass system. And so we could say that there's a negative M2G upwards there. So the net force, the net external force on those two masses is only due to the gravity. So we're going to calculate just the force of gravity on the first mass, 5.5294 kilograms times 9.8. So I get 54.1882 or 18812 newtons. Just going to continue on with part 2. It says, what's the magnitude of the acceleration on the two masses? Well, the net force, the net external force on the two masses is going to cause an acceleration. And by Newton's second law, it's equal to the mass of the system times the acceleration of the system. So that would be the two masses added together. And they're going to accelerate together unless the string was able to stretch, deform. Whatever this mass accelerates at, this one is also going to accelerate at. Yes, it changes its direction because of the pulley, but we're going to take just the magnitude part of it and not the direction part. So they're going to have the same acceleration. So acceleration is equal to the net external force divided by the sum of the masses. And I get an acceleration of 6.3754 meters per second squared for part 2. And part 3, the tension in the rope would be the same on either one of these. It's a Newton's third law type of situation where if the rope pulls on the mass with the force F, and then the mass pulls on the rope with force F, and then that translates through the rope, so the rope would pull on this mass by force F, and then there would be a downwards pull. And so if we find the tension at one end of the rope because of a pull, then we can find the tension everywhere in that rope. So I'm going to say we know this mass is accelerating with the acceleration we just found. What is the force that's causing that? What is the size of the force that's causing the acceleration on just this mass? And then that force would be the tension in the rope. So the force of tension is equal to the second mass times its acceleration. So the second mass would be 2.97004 kilograms times its acceleration of 6.37549 meters per second squared. And we get 18.93 newtons.